Greetings from Malatya. This is Dr. Ayşe Asiye Culum from Malatya Turgut Özal University. I will mention about the Sporopollenin Ekzin capsules as drug delivery vehicles. Encapsulation with microparticles ensures the molecules facing problems such as stability, solubility, and degradation. Encapsulation preserves their natural structures and functions until the place or time of release. The fields of drug delivery are delivery of drugs to the desired tissues, encapsulating fluorescent or colorimetric agents to the carrier molecule for diagnostic methods such as MRI and PET, delivery of healthy functional or super nutritions such as ginseng, echinacea, green tea, glucosamine, omega-3, lutein, folic acid, and fish oil in their stable states without losing their functions. These molecules are susceptible to oxidation, UV, or degradation. Thus, encapsulation protects against these damaging effects. The interest in Sporopollenin Ekzin capsules, namely SECs, is increasing as an encapsulation material due to their stability, uniformity, and biodegradability. This scheme indicates the general process of the loading of Sporopollenin Ekzin capsules. A represents the natural pollen grain. In the first step of the process, the cytoplasm is evacuated from the pollen, and the compounds that poorly bond to surface, such as proteins, saccharides, and fats, are eliminated. Then the drug is loaded into the Sporopollenin Ekzin capsule. So, what is Sporopollenin Ekzin capsule? Pollen wall consists of two distinct parts: the intine, the inner layer of the wall, and the exin, the outer layer of the wall. The exin has been termed Sporopollenin. Sporopollenin Ekzin capsule is obtained from the extraction of Sporopollenin. Here is the cross-sectional scanning electron microscopy images of raw pollen and SEC. In SEC, the intine layer and the outer components of the exin are removed. The advantages of SEC are physically, chemically, and biologically inert and stable, UV absorption properties, amphiphilic structure thanks to aromatic groups such as carboxyl and hydroxyl groups, thermal stability up to 250 degrees Celsius, can be broken down by enzymes in the blood, including nanochannels and apertures that enable molecular diffusion and encapsulation, can be functionalized or surface modified with various reactions that allow applications such as targeting and immobilization to the surfaces. We have investigated SECs from pistachia pollen grains for their direct delivery capacities. The pollen grains were obtained from Gaziantep Pistachia Research Center. For SEC extraction, the pollen grains were mixed with acetone for the fatting step and placed into ultrasonic bath and sonicated for 45 minutes at 60 degrees Celsius. The pollen grains were mixed for 30 minutes, then the mixture was rinsed with water and ethanol. This stuff was preparated for potassium hydroxide and phosphoric acid treatments. Finally, SECs were dried in the oven. The standard protein bovine serum albumin was loaded into SECs by passive and centrifuge loading. SEC and BSA were put into a microcentrifuge tube, vortexed, then placed onto shaker for passive loading and centrifuge for centrifuge loading. Loaded samples were filtrated, rinsed with water, and frozen overnight. Then they dried in room temperature. The morphological structure was analyzed by scanning electron microscopy. The protein removal was detected by elemental analysis. The loading was proved with thermogravimetric analysis and Fourier transform infrared spectroscopy. The first line is the images of raw pistachio pollen grains. The cross-section of pistachio SEC shows that intine and components of Ekzin have been removed successfully. The nitrogen content indicates the amount of protein. The protein content is important because it is the source of allergic reactions. 0.636% nitrogen content is acceptable and demonstrates successful protein removal. This graphic shows the FTIR spectra of BSA, SEC, passive-loaded SEC, and centrifuge-loaded SEC. X-axis indicates transmittance percent, and Y-axis shows wave number. The green lines represent protein peaks, namely BSA. The absorbances of loaded SECs have been increased when compared with SEC, indicating that BSA has been loaded to SECs. The thermogram of BSA consists of 2 steps, whereas SEC indicates 3 main mass loss steps. The first mass loss step of BSA can be attributed to the phenol ring decomposition. After loading BSA, the mass loss steps of thermograms of loaded SECs increased to 4 in both loading methods. The maximum decomposition and the higher thermal stability were recorded between 610 and 620 degrees Celsius in SECs and in BSA around 600 degrees Celsius. BSA shifted higher stability to between 580 to 600 degrees Celsius in loaded SECs. The additional second and third steps in loaded SECs are attributed to carbohydrates, proteins, and fatty acids respectively, which is the proof of BSA loading. SECs are eco-friendly and cheap biotemplates for the use of multiple purposes. They carry a few advantages over other encapsulants with their nature and obtainability by nature-friendly and cost-effective extraction methods. SECs are safe and suitable vehicles for drug delivery, and this study indicates the loading capacities of pistachio SECs by passive and centrifuge loading methods. And thanks for your attention.